Okay, recording has started. By just say by participating, you are tacitly agreeing to be having this call recorded by attending. So
Yeah, that's totally fine.
I'm talking about the rest of you.
Oh, I see.
I have made sure ahead of that with you. So okay.
Do you want to give an intro, or should I just start?
You could start anytime you like.
Okay. Yeah. Hi, everybody. I got invited to talk a little bit of my adventures inside MISA and OpenCL. Also a little bit around, what are my plans or our plans inside the MISA community around SYCL and potentially level 0 or other compute APIs. So yeah, let's start. A few years ago, I was like, looking at the OpenCL situation in MISA, and it was kind of sad. We had, I think, Clover, which was stuck with 1.1 support. And I kind of wanted to, try something new. And I was looking at this and was thinking like, Rust is a kind of hip language at the moment, and a lot of people are talking about it. So that was kind of my reasoning, or like my main way into Rust development. I didn't develop Rust before that, so I was just thinking, use this project as a reason to learn the language and see if we can do all those things we actually need to do with Rust as well. So can we use Rust inside MISA partly for implementing some subsystem or some part of the entire GPU stack? Can we, even implement predefined C APIs like OpenCL? And what does it actually mean for the entire MISA project? Like, how do we deal with the bindings? What kind of abstraction layers do we need? And one thing, or the main reason I choose to, implement OpenCL and not any other compute API is that over the broad compute ecosystem, everything can kind of run on top of OpenCL, be it like HIP or SYCL or something else. It's kind of, felt like the natural thing to implement. And so I've worked quite a bit on this. It got merged last year. It's fully OpenCL 3.0 compliant and conformant, and not on all GPUs yet. There are still bugs on a few vendors, and even on Intel, I have some gaps to close. But it's, it passed conformance and it got submitted and accepted and everything. What's probably the biggest difference compared to other OpenCL implementation is that it's not as heavily LLVM focused as the others are, but it's Spurvy focused. So instead of like all the operations the other stacks are doing on top of the LLVM objects or LLVM IR or something, we do it based on Spurvy. And because MISA is also mostly a stack for GPUs and for graphics API, I kind of wanted to reduce the burden for all the drivers we have inside MISA. So it kind of tries to, look a lot like OpenGL compute shaders for drivers without actually adding any limitations to what we can support on the OpenCL side. We also have I don't know if you know the website, but we have the MISA matrix, that website where you can see what's supported. It kind of looks like this. And you can, scroll down and see what extensions we already support or what optional or core features are implemented on the various hardware we support at the moment. So, and if you want to look at the source code, it lives inside the MISA repository at this path. So, but let's get more into details on how we actually implement OpenCL inside Mesa. And the general compilation pipeline is like we take the OpenCL C source code, we use CLang to compile it to LLVM IR, and then we use the SPIRV LLVM translator you probably all know to get a SPIRV binary. And with that, we actually represent all the OpenCL program objects. We do all the linking based on the SPIRV. We translate this then later to NEAR, which is a Mesa internal IR, and it's heavily GPU focused. And I will talk about NEAR a little bit more later, but with the NEAR, we can give this to all the Mesa drivers, and they just do whatever they want in their backends to compile it at some point to their native ISA. We also use the libclc SPIRV binaries from LLVM to implement most of the OpenCL built-ins. Some are implemented natively because we have native instruction support for that. But that's kind of the general idea on how we do all the compilation. Yeah. So NEAR is kind of our IR to deal with all the shader and kernel compilation, because there were we looked at LLVM and there were a lot of people being really unhappy about this for various reasons. And at some point, people decided on, let's try something new. LLVM didn't really get much adopted inside Mesa. It's mostly only used for the AMD driver. Still is in some parts, but there are people working on getting rid of LLVM support in their backend drivers. So it's a lot. I wouldn't say a lot, but it's kind of designed like LLVM in a few cases. But it's also something completely custom, and we don't maintain any sort of stable API or something. So it's really nothing others could use unless they, have a driver inside Mesa. It's mostly typeless, so all the SSR values are just bit sizes of data, and the operation are defining what's type or what they are doing. What is a big advantage of using NEAR is that we can share all the optimization passes and lowering, and we have there's a lot of code for various GPUs and common things. So usually people just work on NEAR, and then it's helpful for a lot of drivers inside Mesa. And NEAR is usually used for GLSL and SPIRV. There are some other cases, but it's really not important. And it's just used for all the APIs we support inside Mesa. Currently in Rusticl, we have it's not supporting all the Mesa drivers yet, but this is the list we currently support. You can run it on a CPU. It's supported on AMD GPUs, Intel and NVIDIA GPUs, and there's working focus for Broadcom, Mali, and Vivanti. A lot of people are actually asking about Broadcom support because it's used in the Raspberry Pi, so that might be something showing up soonish as well. For the things I kind of want to focus next is currently we don't do function calling inside backends. This is problematic for a lot of big kernels and everything, but something we had to figure out. But the other features are more relevant for SYCL and HIP, which is subgroups, which kind of seems like everybody wants to have. Floating points on 16 and 64-bit things. SVM, which is kind of really annoying to implement and kind of hard to figure out all the details around this. And to get SYCL working, the biggest roadblocker I have is that a lot of the implementations are generating invalid SPIRV, and I kind of don't want to work around that too much. So some of you might have seen the bugs I've created, some of you might don't. And I think it's kind of a little bit difficult if ecosystem or compute ecosystem is built around SYCL and implementations, or like, people trying to consume or run applications have to deal with, invalid Ruby and everything. So, but the ultimate end goal is that OpenCL should also be available on Linux desktop. And it's kind of sad that at the moment we don't really have a good compute story for desktop applications. There's like a lot of talk about, yeah, maybe we can use compute shaders from OpenGL, but nobody really did this. Same for Vulkan Compute, which is kind of, I don't know if it's stuck or if it's not progressing really. But there's not, we don't have a good story, and I kind of wanted to improve the situation by at least supporting something which already exists. So some applications already use it. It's like Darktables, DaVinci Resolve, and Adobe's Photoshop as some examples. I didn't actually try Photoshop, but the other applications we got working. There's still some bugs, but it's something we can figure out. But from the general desktop perspective, it's really just kind of a niche, and outside of professional or scientific applications, there isn't really much compute used. And I think one of the main reasons is that nobody could rely on it just being available, because most of the stacks had some issues. Clover didn't really work, which was like something which distributions could install by default, but still apps couldn't really use it because it's just for one vendor. And kind of my hope is that once Rusticl matures enough and it's just available by default on every Linux desktop, that we can also see like more desktop applications actually make use of compute, be it for video encoding and decoding, which is just a pain on Linux desktop at the moment, because I think everybody knows the problems with, oh yeah, my GPU actually doesn't accelerate video decoding and my laptop is out of battery after an hour. And I think it would be nice if video encoders and decoders could be also implemented in OpenCL, and then just, if the GPU doesn't support it natively, we can still have a fast, power efficient backend fallback for this kind of stuff. Then AI/ML is probably also a big use case, which maybe photo applications could use face detection stuff and other nice to haves for their applications. And maybe there are other CPU intensive tasks which could be offloaded, but maybe compression libraries or whatever. I want to mostly wait and see what people would come up with after it's available. So, yeah, any questions?
I could see. Oh, go ahead. I was just going to say this would be really interesting for the GStreamer folks, which I know they've been fooling around with Rust, especially when you're talking about video encoding and decoding. That was the first thing that immediately came to my mind.
Yeah, I think most of the space really relies on APIs supporting native GPU capabilities around this, like VA API or Vodipro, and now also like the Vulkan stuff. But all those APIs rely on or depend on the hardware actually supporting that, right? So if we even get AB1 on every major vendor and everywhere, you still have all those old systems not being able to do it, and old system will just run it on the CPU, and that's kind of terrible. So yeah, I kind of hope that this could become a major use case for desktop applications. Yes.
Yeah, so you kind of touched on SYCL, which is my kind of major area of interest these days. But I actually wanted to spend some more time on vendor hardware support. Specifically, there's been recent headers being noticed for NVIDIA's CUDA, or their drivers more broadly, adding deeper SPIR-V capabilities, meaning that it offload from, say, Mesa to the NVIDIA proprietary drivers via SPIR-V in Rusticl, RustICL, I forget which you prefer, might be possible. So is that something that's being explored at all? And beyond that, the kind of fun question is Apple Silicon support, if, when, maybe soon, yes?
Yeah. Okay. So, yeah.
Sorry that's a lot there. So
no. That's totally fine. So, currently, Mesa only, like in Rusticl, because it targets Mesa at the moment, really only works on drivers being natively supported by Mesa, and I don't see it changing much. However, there is also Zinc, which kind of brings OpenGL on top of Vulkan, and I was able to make OpenCL work through it on top of OpenCL, on top of Vulkan. So that's probably the path to get it working on proprietary implementations. Because really, if the proprietary stack already supports OpenCL, then it's kind of pointless to route it through Rusticl, because it's just an OpenCL implementation after all. So yeah, I guess if the Intel's implementation just gets the bugs fixed and the SPIR-V is all valid, then I suspect it would also just work on NVIDIA stack. But yeah, I mean, I've seen SPIR-V bugs, so those have to be figured out before that, I think. In regards to Apple Silicon,
just before we go to Apple Silicon, is the idea right now for any SYCL kind of thing to be included in part of Mesa via Rusticl? Is the idea there to provide the SYCL runtime, or also potentially ship like the compilers and so on?
I mean, as I understand SYCL, there's not really a defined runtime, right? You only have the API specification, which is implemented by implementers and targeting whatever runtime they want. So I mostly test against Intel's implementation, because that just gives me OpenCL runtime, which I can use. I don't think that Mesa will do anything like those projects where it's defining all the header stuff or the full compilation tooling and everything, because that's kind of a big scope, and I also kind of don't see the point of doing that. I think, like what I've heard is that there are motivations to upstream as much of the SYCL tooling as possible into upstream LLVM. And we already use, CLang also to compile from OpenCLC to SPIR-V. Yeah, so I would just say, if there will be, an official SYCL runtime API that drivers can just implement to make sure that every vendor's SYCL implementation runs on any vendor driver, then that might be something worth investigating. I was also thinking about how can we integrate level 0 support into Rusticl. But at the moment, especially for level 0, there is not really that much use outside of data center applications. So because I'm mostly also focusing on the Linux system, there's not a big enough pressure to investigate this. But Rusticl is kind of written in a way that it's shouldn't be terribly difficult to support a different API besides OpenCL.
Gotcha.
Yes.
Okay, that's really cool.
Yeah.
And then, of course, the Apple Silicon.
Yes. So I do have a Apple Silicon laptop, and I did got Rusticl to run on it. There are just a lot of bugs to be figured out because even like OpenGL Compute is still very experimental in the Mesa driver. But yeah, once that's mature enough, I would just enable it, and then it should work. No.
You said that all the SYCL implementation are generating invalid PRV or something like that. Can you clarify?
Oh, it's not all implementation. I only tested with Intel's implementation. But yeah, I filed back against Intel's SYCL implementation. And there should be all on GitHub.
It's not fixed?
No, it's not. But I also filed them like, I think 3 or 4 weeks ago. But yeah, there was also like an old bug for me from like last year, which also didn't get addressed. So yeah, it would be nice if people could put more pressure on actually making sure that the SPIRV generated by the SYCL implementations is actually valid. Yeah.
Yeah, I'm curious about which kind of bug it is. Can you summarize?
Wait, I will just. Oh wait, I will paste the link in the. Yeah, here those are many validation bugs. Some I could work around, and some are annoying to be worked around. But yeah, that's a rough overview. I think there are more bugs once those get fixed because the validator only reports like the first error and then just stops. But yeah, you should see the list and yeah. But yeah, it's mostly just yeah.
Otherwise, I'm curious about the HIP implementation on top of Rusticl. How does it work?
Oh, that's currently using the I got renamed again, I think. It's Tipstar, which I tried it with, which is like a HIP on top of OpenCL implementation. I think it also supports level 0. I can also post a link to that. I don't think we want to implement HIP because it's, all the tooling and everything is also like a lot of work. So if we can just, make one-time work, that's fine. But it kind of runs into the same problems as the SYCL implementation as well.
Okay, yeah, I see. So it's not, the AMD official implementation. It's the one from
No,
Finland or
no. Yeah, so the problem with AMD implementation is that they usually generate native binaries, and that's a pain to support. So I don't plan to take native binaries and convert it back to some IR we can consume. But yeah, HIP is kind of a problem because the implementation isn't really covering much. So yeah, it will be interesting to see how much this project matures.
But then, would it be possible to have Rusticl to also take built-in kernels or native kernels, or I don't know what would be the right term here, and just to consider them as opaque and just propagate them down your pipeline by not changing this.
Yes. So OpenCL has the API for native binaries and everything, and this can be used to compile your application ahead of time to the native GPU binary. Just from a because I'm focusing on a desktop that's not in scope, because we actually don't want this to happen. Like, it's annoying if applications only ship with specific GPU binaries, because it's just fragmenting the desktop space. But in theory, it would be possible. It's just not in scope, really.
Well, there will be still the problem that your assumed binary ABI in your OpenCL implementation would not be compatible with binary kernel generated by some other tools. You're just considering, for example, the fact that you might use some external libraries that you might not have, or that might do something completely different from what you expect or whatever.
Right. So external libraries doing that are usually operating outside of the OpenCL specification. Everything is like implementation detail. So if we get like a native AMD GPU binary, it's kind of a lot of work, because then our plan would also be try to make it run on other GPUs. Of course, we could say, okay, we accept this binary and convert it to, or support it only on AMD GPUs or something, and then deal also with the API and everything. I'm just convinced that it's not a working model for a desktop system, because it's good for high optimized code and maybe squeezing out the last bits of % of performance. But I'm also not very confident that it's really needed, because I've even run benchmarks against Wacom and was seeing lower performance than Rusticl. So whatever.
Other questions for Karol? I'm good.
So something else I'm kind of curious about that's been brought up was universal compute, Rusticl being used as a way to support universal compute across the Linux desktop. As of now, certain package managers will have it in, certain package managers won't. There's some kind of points of friction in building it from source with Mesa. So one of my questions is the intention to have this enabled and to push maintainers to, like distro maintainers, to ship this natively? Is that kind of the idea?
Yes.
If you have Mesa, you guarantee you have OpenCL via Rusticl.
Correct. I think it's already enabled in Fedora. I've seen also Ubuntu people working on wiring it up. I think it still lives in the PPA. I don't know if it's upstream yet inside Ubuntu, but they also move a little bit slower than Fedora. I've seen Gen 2 having support for it already. I think it's just because it was merged like September last year. It's still like takes a while until all the distributions will catch up. But yeah, I've seen people being interested in actually packaging it and shipping it. And because it's just part of Mesa, it's really just, making sure the Rust stuff is figured out, which, distributions will have to figure out for Apple Silicon anyway. So I'm not too much concerned about that not happening.
Okay. And then you touched on it a little bit, and I read the various posts on the Git for Mesa. But do you mind touching on a little bit more of what made Rust a particularly good way to achieve what you were looking for?
I don't
beyond
think
Clover just being broken beyond.
yeah. I don't think I've thought about too much. It was more like, Rust seemed like an improvement over implementing APIs in C. And usually if you write in C, then you have a lot of those memory corruption bugs and random stuff happening you don't want to happen. And I've seen like 0 of those bugs happening with Rust. And all of the bugs are mostly from the high-level nature, or the wrapper around our own C code in Mesa is a little bit broken. But yeah, there wasn't like I wasn't really thinking about how why I should use Rust for OpenCL. I just thought, yeah, I want to do something in Rust, and OpenCL just was this kind of pain point in Mesa where everybody or almost everybody agreed that we might need a clean start. Yeah, I mean, there are some good things in OpenCL which maps really nicely in Rust, like all the error code handling is done with the result object inside Rust. And I use, for example, proc macros to translate from results to the OpenCL API return, like error handling, stuff like this.
Okay, because my follow-up then would be, has there been any, this is like a really weird edge case, but GNU has been working on their own Rust compiler and so on. And do you see that as an eventual point of friction and or a target to be used as part of Rusticl's compiler options instead of relying on upstream LLVM, which is kind of hard to track?
Yeah, I think it kind of depends on how quickly the GCC implementation matures. Currently, Rusticl depends on Rust 1.60. And I think the GCC stuff is still like 138 or something. I'm not quite sure. Maybe they even caught up in the meantime. But at the moment, I'm not planning to support it. It just, I think it first has to show that it's actually useful, or like something other project could just, if it's at the state of being a drop-in replacement, then it's potentially interesting to support it.
Yeah. I kind of bring it up because of the old kind of arguments around Clang versus GCC, where each compiler would actually help find different language bugs or different spec bugs just because of their implementation. And if that's kind of being looked at as a potential surface to find different subtle bugs or different optimization paths, is mainly why I bring it up. I'm not asking for you to support Rust GCC. That's beyond the scope.
I mean, the advantage with Rust is that there is no specification, so you can't have specification bugs. Right. So the only thing is really just that if the documentation diverges from the actual behavior of the runtime. And I didn't really see anything of this happening so far. So yeah, I don't think it's a major problem. And the runtime targeting CLang anyway, then it's kind of, yeah, maybe you can drop LLVM in your compilation stack, but then at runtime you still are stuck with CLang anyway. So
So I have a question. So how and this is still around the Linux desktop. What would be projects that like what excites me is the ability for us to use all our hardware. I mean, this is also the premise of oneAPI and our SYCL is to be able to use all pieces of your hardware inside your laptop or whatnot. Since you're definitely looking at this from a desktop and from a desktop app, or especially for uploading, are there projects you want to encourage them to use Rusticl, or even within oneAPI kind of thing? Is there a specific pass or thing that from your perspective?
Yes. So what I think would benefit or would create a lot of value is to figure out video encoding and decoding.
Okay.
I think if people could show, yes, you can use those compute APIs, and if you use Google Meet or something else, then your battery is still up and running after 5 hours, because you don't have to fall back to the CPU anymore. I think that would be something users would really appreciate if that would happen. But yeah, besides that, it kind of depends what's CPU heavy, because like the normal user don't really run into many CPU intensive tasks. They might play some games, but that's already running on the GPU. So I think a lot of users are mostly just complaining about meetings on a Linux desktop are just painful. I don't know. Maybe you also heard about other points of friction with the Linux desktop, which could be solved with compute.
Yeah, I mean, I think about it. I feel like GStreamer also does some. I think there's been some experiments with Rust, but also I think there's been some experimentation with SYCL as well from that project. It's one of the projects I plan to work with in the future. Is kind of see because once you get into media frameworks, right? The applications just sort of upgrade and use everything below it, right? So they get it for free. So the whole GPU offloading and whatever is already handled by the frameworks. So
yeah.
I don't expect application developers to implement GPU offloading. Right? So.
Oh yeah, I mean, yes. If you I would kind of hope that for example, FFmpeg could provide more OpenCL support. But what I've for example have seen in FFmpeg, it's mostly just some filters. It's not really like you can just run your video encoding or decoding on CL. There's like I think for like proprietary software is using it a lot. I think even DaVinci Resolve has some OpenCL encoders and decoders, but I don't know for sure. But yeah.
Yeah, Resolve uses OpenCL. Blender used to, but that's now being moved to to be deprecated.
I think they already
actually that might have already.
Yeah,
I think they removed it recently.
Yes, so the pain point I had with DaVinci Resolve is that the H.264 support isn't enabled in their Linux binaries. That's kind of
ouch.
Why? Yeah, I know that using OpenCL through Wine works on top of Rusticl, but I didn't try the Windows binary yet, because there's also like we still have to upstream GL sharing. It's kind of done, but there's like Rust internal stuff we have to figure out to land it. And DaVinci Resolve is using GL sharing for their stuff. And I don't know how well it works if you run it on Wine and you feed the sharing instead.
Gotcha. Specifically to FFmpeg, from some of the conversations I had on the IRC there months and years ago, OpenCL was kind of seen as a dying target, to put it bluntly. And so there's been a significant amount of work of saying, okay, we can't rely on OpenCL being a good target. Let's instead move to Vulkan for multimedia compute, which is an option. Just because via gaming, you kind of are pseudo guaranteed that you'll have decent and you'll almost always have Vulkan compute capabilities on most targets, especially more on the Windows side of things.
Yeah. I would say that's an option. I just don't know if the guarantees done by Vulkan, like, I mean, it also depends on if you talk about like Vulkan compute as in this project which didn't emerge yet, or just compute shaders inside Vulkan.
Yeah, I think they're basically using glorified gaming shaders. It's not like proper Vulkan compute.
Yeah, so I think it's in the end, it's not really a API problem. It's more of a how to turn those encoders and decoders into proper GPU code, or like into code which runs properly on GPUs. And if people want to target Spivvy directly, or write it in GLSL, then yeah, they could. They could also like write it in OpenCLC or something else and generate compute Spivvy. I think it kind of depends on what people are settling with. And yeah, maybe it will be done with Vulkan, and OpenCL is too late to the party for this. Yeah. But I also don't think that it would be hard to translate once all the code actually emerges to run, also HR264 or something else on top of the GPU directly. Because in the end, it's really just, managing some buffers and then running some shaders.
So I have another question. Did you, implementing this in Rust, did you immediately see any benefits from, like, where would you take OpenCL, like, with Rusticl versus a different implementation?
I don't think it actually matters much, because if you target an API which already exists, then all the language-specific features don't actually escape the API. I think what would be a more interesting idea is how to, if you write Rust code, how can you make use of compute APIs? Because you can't use SYCL for that, because SYCL is like C++, and outside of C++, it doesn't really make sense to use. I think people might want to investigate how to do actual GPU offloading inside native Rust code. It could be that they just target OpenCL directly. Maybe somebody writes wrappers around SYCL. That might also be a potential option, but I kind of don't see a real value in doing so.
I think the memory models are very different, right? I think somebody explained that to me. Like doing it in Rust versus doing it in C++. Domains, right?
Yeah, I don't think that much actually changes on the memory model. Rust is just very specific about initialization, like making sure that you don't have undefined values. But even like, I think it's close to C++ in a lot of, how do you allocate memory? Because you usually, even in C++, you prefer to put all your objects on the stack, which you also do in Rust. Rust just hides the heap management stuff from you. So instead of saying, okay, this goes onto the heap, you just use some container around heap heap allocations, and then you move your stack value inside a container, and then it might get moved into the heap. I think the biggest friction was like the I think the one of the problems is just that in Mesa there aren't many C++ developers, and Clover was always seen as this kind of, oh yeah, it's C++, whoever not touch it. I think it's mostly just a preference that Mesa is written by a bunch of C developers and mostly C developers, and Rust is kind of something a lot of people wanted to investigate. And there will be more Rust code landing inside Mesa. And I think it's just, it's really a personal preference at this point.
Yeah, because this is more of an HPC specific problem with Rust right now, with Rust GPUs specifically, where you have the memory model, and how do you then properly allow for data sharing over the GPUs that never want to touch the CPU and code. Therefore, you never know if something has been initialized on another node when you go to fetch it, or if it's not ready yet for you when you're fetching data across a node or on the other side of the data center. Yeah. So that's been a friction point for CPU only codes. Rust is pretty much fine, and we've seen a lot of work for using the unsafe characteristics, like when you do an unsafe block in Rust, to use that to initialize a C binding, and then use that C binding to go to Fortran binding, so that you can then do, say, BLOS or LIDPACK routines. So it gets messy, but it's kind of doable to access what already exists as very, very well optimized target specific libraries.
Yeah, I suspect if it comes to cross GPU communication, then all you can do is actually just say, okay, either you expose the unsafeness to the consumer, or you just build a contract with the GPU runtime and say, I give you zeroed memory, and then whatever you give me back is probably fine according to the API or something. But it's also like, I think it's fine if some of the undefined stuff leaks. It's just people have to be careful about that not being in places where it actually hurts. I mean, if you have like the CVM model where you have pointers of pointers, then it can get really messy, because the GPU can also just store any kind of pointers anywhere, and there's like no guarantee that it actually points to valid memory. Yeah, so I suspect the solution is, or the answer is just, it has to be exposed to the user, that the runtime can't actually verify that it's all sound, and then it's the user's problem.
Laughing about that on my side.
Yeah, but I think there's not much you can do, except
No, you're 100% right. It's
there's like I don't know if you heard about there's like some SQL stuff going on where somebody came up with macros to actually validate all the query at compile time, and if you put, for example, write the kernels or shaders inside Rust, then you could say, okay, this shader is well-defined and it doesn't produce any undefined values. And then you could say, okay, if you run something on top of this kernel, then the result is probably safe. I suspect that that's like the only way you can do it. And if you would give SPIRV into the runtime, then either you spend a lot of time validating that it's doing something sane, which you probably can't. So yeah.
Gotcha.
But we're down to the last 5 minutes. I guess both Felix and I have been asking questions. Does anybody else have any questions? That
So just a comment on the perhaps, yeah, the last discussion would move Rusticl in a kind of single source of Rust programming model where you could have, in the same way you have in SYCL, type safety between kernel and host side. If you had this single source Rust program model for GPUs, you could solve some of the issues you were talking about.
So this part is out of scope. I mean, Rusticl is really just an OpenCL implementation. However, I was thinking about, like, if you do single source compute inside Rust, how could this, look like? How would you, maybe you do it something like CUDA, where you annotate certain functions to be running on a GPU or something, and then, you have POC macro magic around turning this into SPIRVI or something. But I think that that's still something people should or have to figure out. And at the moment, I really just focus on making the OpenCL side work. But it could also become more, and there could be some people starting to make use of it from Rust code directly. But I think it would be more feasible if that gets detached from the implementation, and then that some trait allowing you to do single source compute inside Rust would just target some specified runtime API instead, be it level 0 or OpenCL, or maybe even CUDA if they really wanted to.
Yeah, makes sense. That's something we've discussed inside the SYCL committee. I will send you some slide with some, I presented about what could be SYCL for us, for example, or Python or whatever.
Yeah, I think like with SYCL specifically, I think it's it's fine that SYCL is this C++ project and C++ developers want to use it. I don't think, I think I see SYCL as being something like C++ specific, and if you want to do something for Rust, then it also has to be Rust specific, and it could have a similar API to SYCL or something completely different. But I don't think there's much value in trying to wrap everything around SYCL that much, because I think, or like a lot of the SYCL advantages you get because you can actually compile your code against SYCL and not have to rely on code generation. I mean, I think code generation would be one way where you can actually would turn Rust code into C++ code and target SYCL with it. That might work. But I think, if you want to do single source in Rust, then it probably ends up being something Rust specific.
Okay, I think we're at the top of the hour. So I'd like to thank you, Karol, for coming here and giving us a talk. I think we had a great discussion. So I'd love to have you come back and maybe do a follow-up on how Rusticl is doing. And thank you. Thanks, everyone. Yep.
Do you actually want to have the slides?
Yes, we would. I'm sure I would love to have your slides. Yes. And we have this recorded, so I'll put it out there. Yeah. So if you want to email me, you can email me.
I don't know if I have your email, but yeah.
Yeah, I'll
you can
just put it on here. If anybody else, And also, if there's anything on any of those GitHub bugs that you need follow up on, please let me know.
Yeah, please fix the spillway bugs.
Yeah, I'll press upon the folks on that repo to do that. They're slow because I know I trusted my own contributions against them, and they should definitely be more responsive. So.
Yeah.
All right. Thanks, everyone. Have a wonderful day or good evening, and hopefully you have a great dinner afterwards. So,
Yeah, thanks.
all right.
Yeah, it's getting time.
Thank you.
Thanks again. This was great.
Thank you, everyone. Bye-bye.